So we want to start today with DevNet scoping. We're going to start with Glamsterdam DevNet 4, and one of the first agenda items. Before I start off, Josh, etc., are we streaming? Are we good to go? Okay, perfect. Yeah, so the first agenda items, Glamsterdam DevNet 4 scoping. Can someone give us a status update on ETH 70 and ETH 71? I think Tony proposed it to be included in the next DevNet.
Yes, I can do so. I think both are ready. I can definitely tell so for ETH 71, but what I hear, ETH 70 is ready too, and all clients have implemented it. For ETH 71, we had it on earlier bulk devnets already, so yeah, things are good to go.
Okay, and I think Bozul had an associated PR with Engine GetBlobs v4, right? I think that's the execution API PR I'm listing here. Is there?
The main issue with
Yeah.
ETH 72 is we currently do not send any blobs on Amsterdam because Lighthouse, for example, cannot handle blob transactions yet. So there's really no benefit in including ETH 72. Also, it is not yet implemented by any client on the CR side, as far as I know. It's only implemented by Geth and Nethermind on the ER side, so it's also lacking support on the ER side. We could say optionally to include it in case you just want to start merging in stuff, but I would not require it. And also, I just see no benefit for including it for Amsterdam. Because it's based on top of get blob v3, and this is just adding get blobs v4 basically. Functionally, it's the same for the CR side. Yeah, it's implemented by Prism and Lighthouse so far on Blob DevNet 0. But I would actually prefer to roll it out on Blob DevNet 0 rather than on Amsterdam DevNets.
Okay, how about we include ETH 70 and ETH 71 and then keep 72 for blob devnets? Would that work?
Yeah, sure. Blob DevNet 0 is already running.
Okay, and I see that the execution API PR has already been merged, so people can coordinate with you, Barnabas, about inclusion in blob devnet 0 for ETH 72. And for Glamsterdam DevNet 4, we would include ETH 70 and ETH 71.
Yeah, it's going to be a bit of a mess because we don't have gloss on Blob DevNet 0. So I'm not sure how ETH 72 would work if it depends on ETH 71, which depends on Amsterdam. So we might need to launch Blob DevNet 1, which is based on top of gloss and test it there. But for that, we would need support from Lighthouse as well. And Lighthouse would need to support blob transactions for that. And at that point, we might as well include it for Amsterdam DevNet. So it's a bit of a deadlock situation.
Okay, but for this, it sounds like we can also just wait for a bit more maturity on the Glamsterdam DevNet side before adding it, right? And I think Bozul has been looking into getting some support so that we can get some early tests in for ETH 72.
Bozo, could you verify if the spec is already frozen?
I'm sorry, what was the question?
Is the specification for ETH 72, is it already frozen? Is it done? Or do we
Yes.
expect any more changes to it?
No, I have some local changes and it's the overall spec is done. Just some details.
Okay,
Do we
then
have could we get those details ironed out and finalize the scope of IT72, and then we can get client teams to actually look at implementing it?
Yes.
okay, but then it sounds like we're all aligned. Stefan also posted that block level access list DevNet 7 has ETH70 and ETH71 as a requirement. So it makes sense to also include it in Glamsydam DevNet cycle so we don't feature drift. And then ETH72 will still get some work from Bozil, and once the spec is frozen, we can discuss including it. Any comments or questions on this? Okay.
So the engine fork choice update v4, that will probably have to be changed based on today's call on this PR in 11444 if we end up including the target gas limit in it.
Yeah, I actually wanted to have that as the next topic, so maybe we can just continue into that. Do you wanna, is Nico on the call, or do you want to introduce the topic, Barnabas?
I hope Nico is on the call.
Yeah, I'm here.
Okay,
So
perfect.
what was it about the engine API change?
It's about the add target gas limit to payload attributes. So you have two PRs listed,
Alright,
one to the
yeah.
consensus specs and the other to the execution API. Could you introduce it and then we can start discussing it?
So I guess the engine API PR has all the relevant context. So essentially what it does, I listed the three main points in the PR itself, is that currently, the status quo is basically we have a static flag on the EL side to configure the gas limit, and we have it on the CL side. With this change, we basically move the gas limit, like the target gas, to the CL only. And when you prepare payload, the CL will pass the target gas limit. So that means it's easier for operators. It also means that it allows to configure it per validator. So you can have different configs per public key. And also for CLOAS, we will need this if we want to use vanilla ELs as builders, because the block you produce, or the payload rather, needs to adhere to the gas limit of the proposer. And the static flag won't work here because you might need to use a different gas limit per slot, basically, when you prepare payload and submit a bit. So yeah, I mean, this is mostly pending because we need some approvals from EL devs. I think from the CL side, we got a lot of feedback, and I didn't see anyone that is not in support of this.
Yeah, I guess we would still bring it up on ACDE one more time unless it's extremely urgent to merge it in soon. But has any EL dev looked into this yet? Do you guys already get the problem or the reason why we want to include this change?
Yeah, the target word might be a bit misleading here. Could we maybe use a different word for it?
Tony?
Yeah, maybe just to clarify, so what would happen is the EL clients could then deprecate their flags for the miner setting the gas limit, and instead the gas limit would come from the CL, but not the final gas limit that includes like obeying the 1/1024 rule, but the gas limit that the validator wants to get to. For example, we are at 60 million and a validator wants 150 million, then the value getting to the EL would include the 150 million. So ELs would then pick that value and would have to adjust. the gas limit that they put into the block accordingly. And I think, yeah, the target gas limit sounds like a good name for it.
Is this okay for the ELs? Because then you guys can, like Tony said, deprecate all of your gas limit flags, and you're fully reliant on the CL to provide you the gas limit. Okay. If there's no objection on this front, is there anything on the CL side? Any cases, etc., that we still need to talk about? Yeah, maybe to Mario's point, what happens if there's no configured target on the CL? I would assume that clients ship with the default. So unless the validator overrides the default, it would use the default in the client, right?
Yeah,
Yeah,
so
both.
just to be clear, I think this should be then 60 million currently, right? Not the 30 million target.
Exactly. Yeah.
Yeah.
So one potential alternative is just to take the parents block gas limit and don't change it at all.
But then how would you signal as a validator that you want the gas limit to change if you use a parent block?
Well, through CL. I mean, if your CL doesn't supply it.
Ah, okay, got it. Got it.
This should be a mandatory field, I think.
Yeah, I think so too. I think it should just be part of the required fields. Porters?
Yeah, so there are two PRs, one that I mentioned in the chat, another one that Justin mentioned in the chat. One is about changing the bid validation over P2P to do the computation to check that it's compatible with the target that the proposer preference expressed. I think we need this together with Nico's PR on the engine. And so this is exactly what we talked about in ACDC. And the other one is changing the withdrawability delay for builder deposits for builders, which I don't know if it's merged, but it's 5223 that Justin just merged and just posted in the chat. I think those two should be on the next DevNet for sure.
I agree. I would like to merge the two.
Okay, so this is consensus specs 5223 as well as 5227, right?
No, it's the first one is a little bit up in the chat is 5236.
Okay, let me just summarize all the required EIPs. So it's the two that it requires PRs. So it's the two that Nico posted, 5223 as well as 5236. Okay, I guess from the EL devs on the CL dev side, there seems to be no pushback, right? Is there any CL dev that doesn't want this change? Okay, then I guess it's mainly a question of EL devs. It would be great if EL devs could have a look before Monday and already start approving the PR to indicate support. And to Mario's point, I don't think they would need to introduce a new flag because they currently send this information to the builder. So instead of sending it to the builder, they would send it via the engine API to the EL.
But it's important that the EL does implement this because otherwise it's going to break something like a Barat's tool to send bids. Because now we're going to put the bid, in the bid, we're going to put the target that is mentioned by the EL. And that's, well, we don't want that one to be wrong.
The engine API will have a mismatch if the CLs are pushing this field, no? It's not like we're not gonna notice this.
Well, so the thing is that the EL should deprecate their flag and actually just not listen anymore to their flag if we send something over FCU, but then they return a block with the gas limit that was because of their default flag, then we might have a mismatch there, and we're only going to see it on propagation of bits.
No, we can check this on the snooper as well. We're gonna be able to see that very quickly. We can verify that quite easily, I think.
Yeah, this seems relatively straightforward to test as well.
Yeah, no, to test is fine. It's just I don't want this to be broken from the start.
Yeah. Yeah, agree. Are we agreed that we wait on all of these changes for Amsterdam DevNet 4? So all of these changes go into the next DevNet.
Yep.
Okay, then I guess priority would be EL devs to have a look at these changes ASAP and leave approvals on the PRs. And we can bring it up again on Monday if there's any questions. Yeah, Portals?
Could we merge dual deadlines and even put if we want to keep the timelines as today, just put the same timelines for the payload availability and the DA availability, so that requires no code changes on clients. But I would want to have already merged dual deadlines so that we can actually start benching soon. This is sort of like a requirement if we want to cap. Well, I guess for those, if you guys are not following, there is a problem if a payload executes into the next slot, in which any builder can actually reorg the next block, and we cannot solve this on the consensus side. We need to cap execution in such a way that payloads cannot execute into the next slot. And the way to do this is by just not allowing gas limits that would execute into the next slot. And the only way to do this is by reorging late payloads. And the only way to enable this in a reasonable way is by having these dual deadlines as well. Otherwise, today we just have 3 seconds.
Could you link which PR this is?
Justin already did.
Okay. Yeah,
I just did.
Use different deadlines for payload and blob data availability.
There's 2 of them. One is that, and the other one is forcing the proposer to reorg. We will have an implementation for this in Prism as soon as the other clients as soon as we are allowed to start reorging blocks. Today, the DevNet is not stable enough that we can actually test this. But I would want to have these PRs already merged in the spec so that it's not a hard fork and we can just start reorging blocks and we can just start sending these different timelines and PTC attestations whenever everyone is already implemented them.
Tony?
Yeah, I would very much support that because the dual deadline seems like it gives us a lot of scaling for trading off a little bit of time for worst case propagation time, but we have enough for that anyway. So yeah, very supportive. The only thing I was wondering is why would we ever end up in a situation where we execute into the next slot, assuming we know exactly how much time we have for the execution, basically when we set the dual deadline. For example, let's say it's at 8 seconds, then we know we have exactly 4 seconds until the next slot. And based on that, we would never pick a gas limit that would end up with a worst case execution time longer than 4 seconds.
Yeah, no, that's absolutely fine. It's just that today we're testing already by default on 200 million. And that's far more than the 3 seconds we have now to execute them.
Okay, great. Perfect. Yeah. Sounds
I guess the main feedback here is from the other CL teams, right? Has any other CL team looked into this? Are there opinions? Okay, Nico said it looks good to him. Yeah, Justin also said it looks good, but needs clients to weigh in. Dustin, could you expand on mechanism designed to be disabled?
Sure, yeah. So I want to be very clear that this is not for, against, or around, etc. dual deadlines in any specific way. What I'm saying, this is as a more quasi process point to a degree. What it is that if POTUS is introducing this as let's not change, no lines of code need changing, etc. Fine, but then there's no value in the spec and changing either. If the spec and if he wants to start benchmarking, which again, that sounds great, but then it's effectively custom because by saying none of the code needs to change, that this is quasi hard fork material. I mean, it's, we're in DevNet territory, so hard fork doesn't mean quite as much here right now, but so it's one or the other, but trying to pretend that, oh, the mechanism's there, but it's not implemented, but actually the spec is there, so it's okay, we can start using it, is incoherent. Either have it be real or don't bother with the spec change. That's my position.
Yeah, POTUS? I guess POTUS was mainly responding to.
Oh, I'm sorry,
Dustin,
I was
or,
muted.
Yeah.
So
Yeah.
the point is that the deadline, as in the CIP and this dual deadline, and even just the PTC deadline itself, is completely irrelevant at the moment. And the reason that it's completely irrelevant at the moment is that we are all ignoring PTC. We just build on top of whatever our head is. So if we see the payload, regardless of whatever PTC did, we are going to build on top of the full payload. So changing the deadline or not, enforcing it or not, it's just completely irrelevant at the moment. And it only is going to start mattering when we actually start reorging blocks that the PTC voted against. So that's the reason why I don't mind any sort of deadline we put. Having said so, I do think that we need to put different deadlines instead of the same deadline as I suggested and as Justin mentioned. And the reason, again, is that today it's irrelevant. We are not using it. And anyways, on any testing that we're doing on DevNet, the payload is being revealed at second 0 with the block. So it's not going to change if we put it at 6 seconds.
Okay, sure. I mean, again, I'm not against dual deadlines, and I understand sort of the reasoning here. It's there's a the okay, to the degree that this is, as you're saying, kind of ignored already, then it's kind of, there's a no-op aspect or quality to it. Yes, I agree with that. However, this is explicitly asking for, I guess I don't know what if, how, so I'll start over. If one is going to have to customize this anyway to do benchmarking, because as you say, nobody has been implementing it, or maybe some people have, but it's not broadly implemented, then what is the gain in having it in spec one way or the other? Because you're not going to get interoperability across a DevNet at that point. You're going to be doing some custom thing with one or maybe two clients. So what does it matter whether it's in the spec, conversely?
Oh, no, I wanted to have in the spec so that we start running now without any changes. And when every client, because I want to give time to clients to merge this. So I don't want to delay the DevNet 4 because of this. But if we agree that this is going to be there, we launch DevNet 4. Whenever we get a green light, because every client already has implemented this correctly, then we're going to start reorging payloads.
Okay, sure. Okay.
I guess it's more of a blocker for when we start the testing, but not for when we launch the DevNet, right?
Exactly. Yeah. I don't want to delay the DevNet. But as soon as everyone tells me we're already good with this, we're going to start reorging blocks and actually checking this, actually benchmarking this.
Yeah, makes sense. Barnabas?
Yeah, so just for Dustin's point, we usually go from spec to the tooling side. So if there's a new value that needs to be tested eventually, then it's better to be in the spec than not be in the spec, because we usually don't add the fields until they are merged into the spec. So if we know that we want to be testing this in the coming weeks, we should actually merge it in, and then we can add support for these fields in all of our toolings, and then we can start moving those fields around in like kurtosis and on the DevNet as well, without requiring a hard fork.
Okay.
Yeah, okay, sounds good to me. Then Justin, would you be able to merge them in today?
Yep, I think we can.
Okay, thank you. Yeah, I'm guessing there's also going to be a spec release, and then we can target the new spec release for the next DevNet. Sounds good. The next, is there anything else to discuss on this agenda item?
There was a note I wanted to merge about pre-validating pending deposit signatures. I can try to find the PR. Pretty much I realized that if there were a lot of new builder deposits at the fork, it might stall some clients. I would just like some reviews on this, and if it's a good idea, we can merge it, or just a suggestion.
I mean, you could technically make a deposit right now with 0x03 credentials, right? So how long should that cache live?
No, because sorry, it would have to be in the pending deposit queue at the time of the fork. If you made the deposit now, it would be processed well before loss, and it would actually just be lost.
I mean, we have a 4 months queue right now.
I mean, if you think, yeah, maybe.
Yeah, please have a look at that PR, and I guess the node can also be merged in if there's no pushback.
Yeah, maybe. It's also not critical. We can always do this later.
Yeah, for sure. The next big agenda item. Sorry, did anyone want to say something?
Yeah, so the entry queue right now is 63 days. So I'm just not sure how big of a cache we are prepared to work with here. We don't know like how the queue system is going to go on mainnet in the coming weeks and months. So this might be a bit more hard than.
We could just start putting them as soon as we put them in the queue. As soon as we process a deposit request, we can just start like validating signatures right there on the free time, and just make sure that we keep them in the queue already tagged. That's an easy change.
Yep.
Okay. Sure.
Yeah, Spencer.
Yeah, I just wanted to ask a question because I'm a bit confused on like where the EL side fits in with the DevNet. So this new DevNet now, Glamsterdam DevNet 4, I'm assuming is going to use the BAL DevNet 7 branches for the EL, or is it using the BAL DevNet 3 branches? And is this DevNet mostly to test the CL? And then I'm assuming the next DevNet after that, Glamsterdam DevNet 5, will have the remaining EL EIPs included.
It really depends on how stable BAL.NET 7 will go. If we still see some 73 issues, then we're just going to run again with a single EL, because there's no point of debugging two different issues on the same DevNet. So depending on when BAL.NET 7 launches, I think Stefan mentioned that they want to launch on Monday. We could possibly launch either a few hours after that or on Tuesday.
Awesome, nice. So is it safe to assume that the remaining EL EIPs will be included in a Glamsterdam DevNet 5?
Yeah, I would
think
not
if
increase
everything
block. Yeah.
is Yeah, I think if everything is stable on PAL 7, and we're able to merge it into Glamps and Glamsadam 4 is also stable, then let's assume that the remaining EIPs go into Glamsadam 5.
Thanks, awesome.
Also, it would be nice to discuss if we want to include anything else in Amsterdam 5 on the CL side. The remaining CL EIPs.
Yeah, but I'm guessing we can do this in the next ACDC.
I think it would be good to set out a target because realistically, by the next ACDC, we want to have the Net5 up and running already or very close to it. So it would be nice to know which EIP we're going to be working towards in the next few weeks.
Yeah, that's fair. I just don't have it on the agenda item for what comes in next. Maybe we can do this on ACDT, so we have some time to prepare for it. And also, we just have a lot to test. So I would stop. I kind of follow Potus's message here. I think there's a lot of implementation and features to test. If we keep adding more stuff, then we're already kind of we're chasing a moving target, and at some point we have to start testing what we have. The next agenda item I had was relating to builder deposits. So we've already discussed increased withdrawability delay is going to go in, but there's also two EIPs. One second, there's the cap deposit request per block EIP. Do you want to introduce that, Barnabas? I've mentioned the EIP here.
Yeah, so this EIP basically proposes that we're going to be limiting the number of deposit transactions on the ES side instead of on the CS side. And multiple people raised that this could lead to different kind of those factors on the ES side. And it would be rather difficult to implement it in a efficient manner. So I'm not sure if this is still the best idea going forward.
Okay. Maybe as an introduction to the topic, we're still missing the data for knowing how big of a problem it is, right, with builder deposits. As far as I know, only Teku has a log line that prints out how long they take to process the deposits, and we don't have the data from the other clients.
Yeah, we don't.
Yeah, Terrence?
I think benchmarking or having a more complete design around this over the last few days. So I think from where we are standing, and keep in mind that the machine I'm using this is like an M1 Max, so it's slightly more powerful than what typically people use, is that for 8,000 deposit, 8,192, I can batch verify everything in like 800 milliseconds already. And then if there is failure, then I think the most optimal algorithm I found is essentially batch verify in the chunk size of 8, and then you just recursively, and that get us to say if today there is like, I think I found the worst case is say today if all signatures are failing, then it will take about 6 seconds to verify that. So that's one thing that I have is a batch verifying number. The second thing I have is that I added a post-processing cache, meaning that as soon as you get the payload, you can already start verifying the deposit and just cache the result, right? And so that kind of depends on when the payload is revealed. So if today the payload is revealed at the 6-second mark, then it's probably fine. But if the payload is revealed much later, then there is a chance that basically that we will not finish, and the proposal of the next slot will not have enough time to like propose a block. But that also assumes the attacker will have to make invalid deposit, so like essentially burn some ETH in order to do this. But yeah, But I guess like in the happy case, it's perfectly fine. In the unhappy case, where it's up to how many invalid deposits are there, then the next proposal may be screwed.
How are you getting the processing times from Prism? Is there a branch or something that we can run? Because we have reference hardware. We can probably add an asserter test for having invalids and then benchmark. Now we would have potentially 2 clients to benchmark, Prism as well as Teku, and we have a few more numbers to work off of.
Yeah, so it's in the branch that I've shared in the Discord. I think it was in the thread or something. It's called Glamsterdam DevNet 3 deposit. I will type the branch name in the chat right now. Yeah.
Okay, perfect. So yeah, Barnabas?
Any reason this is not just merged into your Amsterdam DevNet 3 branch?
I don't like merge like code that like I'm not like 100% sure into DevNet 3. So I think what I will end up doing is like I don't know like how urgent you guys think this is. Like, can you guys leave with a separate bench for a few days? Then I will open PRs for review and get those merged, and it will be much cleaner from our end. Yeah. So yeah, basically you let me know how urgent this is. Like, I'm happy either way.
Yeah, I think a few days is perfectly fine, so we can work off
Yeah.
of branch for a few days.
Yeah,
We'll probably just start testing and benchmarking with Prism and Teku, and then add the other clients. And
Maybe we could
regarding
hear from others as well, if they are making progress on this.
Yeah, is someone from Lighthouse around? Would we also be able to get a Lighthouse branch for this? Okay, perfect. I think there's a Discord thread, Kingy. Could you post the branch when you have one over there? We just need processing times from Lighthouse, and then we should have everything to gather the benchmark numbers. Okay, I guess the next follow-up question is for the overflow issue. One option is, of course, fixing it via 7688, so that's forward compatible structures. But is there any other options we have on the CL side? I know that there were discussions even to reduce it. Yeah.
We could increase it to like a million or whatever. But I would prefer not to introduce a new variable when we're gonna be just removing it 87688. So I would just say that for Amsterdam DevNet 4, we're gonna cap the gas limit to 190 million, and then we're not gonna be able to reach this. Nobody can accidentally trigger it. And then once we include 7688, possibly in .NET 5 or 6 or 7 or wherever we decide to include it, then we can actually push the gas limit up to 200 million.
Okay, sounds good. Anything else on builder deposits? Great. Yeah, go ahead.
Oh, sorry. I was going to say, I think Terrence has proven that it's not strictly necessary to have a queued builder deposits. I think that client optimizations is the path we should take.
Yeah, I definitely like that more than a new deposit contract path. Great. Okay, the next agenda item is adding SSE to Engine API. And there were 2 proposals, one from Marius and one from Barnabas. And is this something that you want to propose for the next DevNet, or is this something we can delay a decision on?
This is an optional thing, so anyone can optionally include it or not. I know that Nethermind now has merged it in to their master branch already. So that's actually front running any TL teams as well. So I'm actually quite surprised.
If I can add something, yes, we merged it to our master branch. We also supplied a few PR changes on top of Julio's changes to Prism, which we tested it with, because the spec changed between Julio's initial proof of concept there. And we achieved actually quite a big improvement over JSON, around 5 to 10x, depending on scenarios, on a very like congested scenarios, on very like heavy scenarios of I think get blobs and get payload. Those are the ones we tested.
Yeah, Barnabas, can you first explain the difference between the two PRs?
Yeah, so my PR is basically translating the whole existing API structure into REST and using basically the same names at the same endpoints, just using a different version type, how you would do in Rust. And Marius basically wants to use named forks. So like instead of engine new payload version 1 or 2, it would just be like Amsterdam payload and Osaka payload. And he would want to basically back implement it for Cancun, he said. But yeah, he didn't specify how far he wants to back implement it. And my proposal would be basically to implement all the versions all the way back till version 1 for everything.
So
Yeah, Lucas?
one more comment from us. It was easier to go with Barnabas version without changing the spec at all, because we reused the same types internally and only did a different transport layer and the coding layer, and it was relatively easy to implement. So it was fairly straightforward to add. And the doing SSZ in because we have our own library and our generators for SSZ, so doing SSZ for us was relatively hard. Although Alexei is working on SSZ for years now, so we are in a good place, but it was still relatively not easy. And also we made it in a relatively optimal way, so we also like serialize and deserialize directly from the wire. So yeah, without like copying buffers. So because we wanted to do this for performance, so not touching the actual structure of engine API made it a lot easier for us, and we could focus on those concerns.
Yeah, that sounds good. I guess the main, it also sounds to me that Barnabas's approach would be way easier and quicker for clients as opposed to Marius's, but maybe for now, since it's optional anyway, if there's any CL with some spare capacity, would you guys be able to work with Nethermind to prototype, try out both options and see which one you like more? And then we can make a decision in the future. Yeah, I like that it's optional and we don't have to tie it to a hard fork or, tie it to a DevNet or anything.
It would be actually quite interesting to see DevNet deploying both SSD and GSM with like different versions and see if you can actually see a huge benefit. And I would expect.
I'd assume that you'll notice the big benefit once we start doing a lot of blob spamming.
Right. Yeah.
Yeah. Okay. Potos said there's another PR under review, and okay, so we might have to.
No, this is just in the
No,
implementation
that's
for
different.
Prism. Julio opened this a while
alright.
ago, and then Nethermind on top of that fixed the PR from Julio. And there's several team members, I think they are here in the call, that are reviewing those PRs.
Okay, awesome. Then it would be really nice to next Amsterdam DevNet, so we can actually see some real numbers. And in the
Uh,
meantime, if someone has strong opinions about if you want to refactor the entire naming scheme, then please speak up. But otherwise, I guess we go the lazy approach. Yeah, Barnabas.
my main question would be whether we want to start merging this in now that we have a client implementation, and then iterate maybe on top of that.
I guess the main
Or
objection against merging it in is we don't know if we which approach we want to go with. If we want to rename the whole thing, or if we want to just add SSE on top.
maybe someone from Gas can speak on behalf of Marius. I'm not sure if you guys discussed this internal.
Yeah, since this isn't a blocker, maybe we can just leave it as is and then collect some more opinions. And yeah, agreed with you. Add it to the ACDT agenda, and then we can merge it in once we have consensus. To Light Client, the question is if there's two PRs for the engine API for SSEing it. One reimagines the whole thing, and the other one just essentially renames stuff and adds SSE. So which one does Get have a strong position on which one they want? Okay, let's move on from the topic. Yeah, we can bring it up in ACDT and take it up there. Any other Glamsterdam topics for today? Okay, then let's move on to Hegota. The first item on the Hegota agenda was committee attestation broadcast specification. This is from Sukun. Is Sukun on the call to introduce it?
Hey guys, hi. You can hear me.
Hey, yeah, go ahead. Yeah.
Wait, let me share. Yeah, you can see my browser. Okay. So yeah, first I'll just to briefly give a background of the current attestation thing. It will like be very quick. I presented some of this work at the interop. I'll just go through all of this quickly. And the aim here is to basically increase our subnet sizes, like the commit sizes in subnets, which we use for attestations, and to increase them by 4x at least, so that we can cut down the epoch time by 4, basically, and get to 8 slots per epoch. To do that, basically, what we need is to just reduce bandwidth use for attestation propagation. Like attestations are the reason why epochs are 32 slots. Like rest of the traffic flow does not really change within the slot. Like the only thing that is the bottleneck is how much time we have for attestation propagation, and like how many validators are voting on a committee, and like how quickly can we disseminate them and aggregate the votes. Okay, so like Gossip currently works with a mesh size which is of 8, and a mesh peer is basically someone whom you would always forward your messages to. Like this is not a push-pull thing. You just always push everything to your mesh peers. And every heartbeat 700 ms, you do a basically sync with some set of your peers who are not your mesh peers and tell them these are the list of attestations I have. And that peer subsequently can request those attestations from you. Like they are called I have, I wants, but like that is generally, like that is the mechanism here. A brief overview of what's happening currently is that all beacon nodes subscribe to 2 subnets. And this basically subscription stays for roughly a day. Like they're supposed to stay in a subnet for a day, provide a stable backbone. And then every slot, a different committee of validators will vote on that subnet. Importantly, these validators are not participating in exchanging these messages to other peers. Like they are just voting on the subnet. They will pick one of these nodes on the subnet and just give them their message that this is my attestation, and these subnet peers like take care of like forwarding to everyone in the subnet. The whole point of having the subnet is that there are 16-ish, I think, like, yeah, it depends on that specific slot, validators who are given aggregator duties, who are also part of the subnet, and the entire subnet only exists to to anonymize the aggregators so that you don't just DOS these 16 nodes on the network. Okay, but other than that, subnet nodes play no real important role here. Like, and the smaller the subnet, the better. Like, if 128 is nodes are enough for us in a subnet to anonymize, like we should keep it at 128, not increase it to have more beacon nodes joining the subnet. So jumping into like the proposed changes and like why current system is inefficient and how we can improve this thing, right? So basically, yeah, the biggest inefficiency is that we send every message independently. So every message has a attestation data and the signature. And this roughly comes out to about 200 bytes in total, 220. And then on top of it, you have the gossip subtopic name. So this goes to 270. And like on the wire, you will also have IP packet sizes and all like this. So that adds another 40, but it's not counted in the measurement. And we simply propose this idea that wait for a few milliseconds, like 20 to 50, and then basically batch all the attestations that you have with which are attesting to the same attestation data, and just send the list of signatures along with like their validator ID, committee IDs. Oh, okay. So this basically reduces the data transferred over the subnet to half. Okay. Moving on, there is another inefficiency in gossip sub, which is this part that I mentioned, that for non-mesh peers, you will send your gossip I have, I want things. And these list of messages that you exchange with your peers every heartbeat, they take 20 bytes per attestation. But we can do much better. What we can do here is we can basically only send attestation data along with the bit list of validators who are attesting to that attestation data. Okay, I don't have the details. Okay, yeah, I have it in this line. Yeah, and so this change reduces the total basically gossip happening on the subnet from like 10 KB times the number of peers you gossip to about 220 bytes. Like makes this total number just negligible. And like on running beacon node, I am measuring that about 30% of the traffic is of this gossip basically. Oh, yeah. So that is another thing to reduce, improve here. Similarly, Gossip Sub has this topic that we send on with every message that we send, which is like 40 bytes. And so we can cut this down to either 0 or 4. Like if we make a bigger change, we can cut this down to 0. If we make a smaller change, we'll get this down to 4. I'm not seeing the chat. If there are any comments people want to say, I'll just say them.
We can do comments at the end if you want.
Yeah, sure. And that also works. Yeah, the other thing is that our D value is high. 8 is pretty high. We can, like anything between 4 to 6 should be fine for us, like which I'll share the numbers later on. D value is basically your mesh size. These are the peers you will unconditionally forward to. And so this number is always D minus 1 because as soon as you receive a message which is unique for you, you will queue it to all your other peers. Other peers by I mean, you will exclude the guy who gave you the message, but everyone else will be just enqueued. So you'll just eventually end up forwarding to D minus 1 peers always. 8 is pretty high. We can cut it down to 4. And like, yeah, I think 4 is good. So like to give some background about like how to think about this number and how to think about like the time of propagation for attestations. It's like a function of the subnet size and the committee size. The more committee members you have, the more data you have to transfer over the subnet, right? And this increases your like transmit time, which is like the total time it takes for you to put things onto the wire. Like it's roughly the amount of data you transfer by your bandwidth. On the other hand, there is another factor, which is subnet size, that if you have a smaller subnet, your graph is small, your graph diameter is small. And so it's just faster to propagate within the subnet. Like, to think of it this way, if the subnet size were 2, it would just take you 1 hop to send it over across to your peer. So yeah, and then if you increase your subnet size, it's actually worse for latency. But we do want some threshold amount of subnet to anonymize the aggregators, or at least not change that property. And so I have this proposal which does all of these changes. It's currently in ETH2P. I will move the consensus changes into a consensus spec PR. But roughly this is the idea, basically, that we have this attestation data, and rather than sending it again and again, you send it, the attestation data once and just send a list of signatures which are signing to it, and a bit list for the signatures, basically, who are the validators who have sent those signatures. And same way for gossip, you send the attestation data with which attestations you have, and basically which attestations you want from the PA. The current proposal builds on top of the partial messages proposal, which is being done for blogs. I intend to try a custom protocol as well, and then see. The benefit of partial messages is that we get backwards compatibility very well, because you will share your mesh peers with peers who don't support partial messages, and you may potentially be able to just deploy it anytime you like, sort of, like after testing, of course. But it does not need to be coupled to a fork, and like it's just much easier to deploy it that way. Yeah, so now for some like numbers, basically, as to like the simulation numbers. Yeah, so this is the red line that you see here, which is like the current state of, and these numbers roughly correspond to current mainnet. There are 500 members in a subnet and 500 committee validators who vote on that subnet. Okay. And yeah, so the proposed design is the blue curve. The current thing is the red curve, and we move from about 800-ish for maximum propagation to around 500 to 600 ms. We get the expected, basically, reduction. Ignore the ID list here. A bunch of things I was trying. From basically 1.2 MB sent per mesh to about 1/3 of it, basically, because of all of these improvements that we showed before, and like primarily because like we reduced the gossip overhead also a lot. Okay. So then this is basically the simulation for 1,000 validators voting on the subnet. So basically, no subnet assignment is changing. We're just saying we reduce the slot size, basically the epoch size, by half. So we have twice the number of validators voting in the committee. And we basically get this curve, like D = 8 curve, which now has shifted from previously 500 ms to around 600 ms. And more importantly, if we reduce the mesh, like fan out size, like the D value, we are now getting like much better numbers. Basically, this reduces the bandwidth used to. And like, if you have 2,000 validators voting in the committee, you get much better numbers with like 4 peers in your mesh. But the important point is we roughly get the same performance with 2,000 validators in this new system on a committee as we get in the current system with 500 validators. So it's a plausible path to like reducing the epoch a lot. That's about it. I just want to highlight it. Basically, I would like to propose it for Agata at least, and I'll try to make it in such a way that it's backwards compatible, so we can just deploy it without a fork. And these are some of the other steps. The
I think there's
specs are
a
updated.
couple of questions. So, Kun, do you want to maybe take those? We wanted a 10 box for 5 minutes from now, and then there's a few more EIPs to discuss today.
Yes. Okay. Do people just want to ask the?
Oh, I have a bunch of questions. I very much like this, and I think the high level discussion we should be having is as an approach for faster finality. It's contentious. It's contending this thing of like having more committee members per slot and having less slot per epoch with shortening the slots. And I very much like this approach of shortening the number of slots per epoch. What I do worry though is how does this play, for example, with a faster confirmation rule? If we get a less stable voting per slot, then perhaps this would make the fast confirmation less effective. And today we could, presumably with the current status, be confirming or getting a good signal that we're final with just one slot. But if we go with this, it's not really clear to me how it would affect. It would be good to have numbers as to what is how the vote effectiveness is going to be changing.
That's fair, and I will consider it. I don't have any analysis here, but intuitively, like say if we just move to like cutting the number of slots by half, the system would have actually better transmission properties than the current system. And like the fast confirmation rule should work better with this one. Like it in no way degrades it from the current status quo. Though, yeah, it's a fair question that maybe putting it at 4x might be a stretch. And yeah, that requires a bit more analysis.
And just quickly, the other two is that on the technical side, I mean, I don't really understand this thing of like trying to make better the I want and I have. If in Svalbard you guys told us that it's essentially useless today, and even if we drop it, the only thing that would matter is that some aggregator might not get some good single attestations. I would just drop the entire system instead of like trying to make it better. And the other one that I wanted to highlight is that on the attestation data, if you're going to be changing it, we should really study dropping completely the checkpoint, the target checkpoint and the source root, because those can be derived from the block root itself at the cost of not being able to slash invalid attestations that are anyways useless because they're not on chain.
I will consider that, yes. So both of them, like intuitively, I felt that I have and I wants probably help these nodes who are not like in Europe and US, and like I was just generally finding it difficult to be in the mesh because like over time we have these subtle rewards in Gossip Sub for giving you a good message, like giving you the first to deliver a message, so that meshes tend to move towards like your nearby peers. So intuitively, I think I have and I want help those peers, but I would like to like measure it on the mainnet and then take a call. So, but yeah, I am on board for it. Of course, if it does not help, we should just remove it. What was the second point? Yeah, in terms of attestation data, I will also consider that. Basically, yeah, actually for the I have and I want gossip, we actually don't want the whole attestation data, right? We want the checkpoint. But it's fair that, yeah, if we just get the final blocks vote, it is correct. And I guess it also simplifies things a bit. So yeah, that is a great point. I'll take that up. Okay, which are the other questions? Barnabas, what's the rollout plan for ETH P2P? I actually don't have a good answer to that, but you'll have some amount of overlap with libp2p. I think it feels like, or at least if we don't have a libp2p overlap, we need a way to say this is how you run Gossip Sub over ETH P2P, which might be also a fair transition plan, but nothing's finalized here, so I don't have a good answer to your question. What are the other questions? Does anyone want to go ahead?
Just for the rollout plan, I would actually recommend to basically have some feature flags to enable the different, like ETH P2P and disable lib P2P, or enable both at the same time. And that way we can actually just test if everything is going smoothly and we don't like require twice the bandwidth to send stuff on ETH P2P and on lib P2P ever in production.
Yeah, I think that's a good point. Like Jacek also mentioned that we have like 5 networks now or something if we introduce ETH P2P along and everything else in parallel. So yeah, that's a fair argument. On how does this affect the fast finality roadmap? In general, it does not affect much if we are doing a decoupled consensus thing. What will help, like I removed that slide because it wasn't relevant to what I'm proposing for Hegata, but is that this method actually is fast enough for like aggregating 8,000 committee members in like 2 seconds. So it will actually help a lot in a decoupled consensus where the finality chain has a completely different slot, where you just have a lot more committee members voting on a slot, but using just the same method. Does that answer your question, Greg?
Yes, thanks.
Okay. Yeah, I think that's it. I just wanted to highlight that we are working on this. Please, talk to me whatever feedback you have, or if you have any questions. Yeah, and I'd like to propose it for Haggadah.
Awesome. Thank you. So we would still wait for 2 weeks before we accept it, I guess. But yeah, if there's any questions, etc., please reach out to Sukun. Yeah. The next item on the agenda is EIP 8025 from optional proofs. Is there
Yep.
who's
I'm here.
presenting this? Yeah,
Yeah, it's
Ignacio
Francesco
or
here.
yeah.
Can
Okay,
you hear me?
Francesco, go ahead. Yes.
Yep. Okay, cool. Let me share my slides. Can you see the slides?
Yes, looks good.
Perfect. Yeah, so it'll be myself and Ignacio presenting this. We're both part of the EF ZK EVM team. The ZK EVM team have been kind of collaborating with the broader community for some time of this on this effort. And I will kind of provide an update on the status of that progress, at least on the CL side, and then Ignacio would do the same on the EL side. So yeah, the proposal here is to include EIP 8025 in Haggadah, and it is an optional proofs EIP. So TLDR on a high level, the EIP essentially covers the introduction of execution proofs into the protocol. So an execution proof is essentially a cryptographic proof that allows a validator to efficiently assert the validity of an execution payload. So we introduced this cryptographic proof into the protocol with 2 additional modes. Now, it should be noted that these modes are opt-in. This is a completely optional EIP, so standard validator mechanics are unchanged if they don't opt in. The 2 modes are proof generating mode and proof verifying mode. So for the proof generating node, essentially an active validator will kind of enable this mode on their beacon node. And whenever they receive a block, they validate it via re-execution, and then they will make a request to the proof engine, which I will kind of describe in more detail later. But essentially, there's this component called the proof engine, which is responsible for both generating and verifying proofs. So the active validator will request the proofs from the proof engine. There's an external proof node, which potentially has GPUs and other kind of hardware required to generate these proofs. The proofs will be returned back from the proof node to the proof engine and subsequently to the beacon node, essentially the validator, who will sign the proof and subsequently gossip the proof on a new execution proof gossip topic. Then the second mode is proof verifying mode. So you've got another node which is opted in to verify proofs. So this node will essentially receive the proof over the gossip topic, and it will send the proof to the proof engine, which will subsequently send the proof to the proof node to be verified. That's kind of the high level flow. As I say, this is opt-in, and in addition to the standard kind of duties and node operations, so we still expect that nodes will do re-execution in addition to these additional modes. And I'll dive into the reason for that later. But just to give some context in regards to the motivation, the key benefit of this is that we make payload validation sublinear and stateless. So specifically, it's sublinear in the gas limit and the state size. So this has nice properties in regards to the hardware requirements for nodes. And the implication of this kind of sublinear relationship is the fact that payload validity or payload validation is remains accessible even with gas limit and state growth increases or state increases, state size increases. In regards to why optional, the technology is still relatively novel. There has been a lot of development and progress over the past few years, but in the first instance, we'd like this to be optional, such that we can kind of collect data and build confidence in the system, make optimizations, etc., before we do, potentially enshrine this in a future hard fork. In addition to that, we don't want this proof verification to be load bearing on consensus. We essentially want this to as a phase where we can build confidence and just kind of test out the various components of the stack before we enshrine and make this load bearing on fork choice and consensus. So why in Hagota? As it's mentioned, the technology has matured substantially over the past few years. L2s have deployed roll-ups and they've had them operating in production for a number of years now, and proof systems have improved in regards to efficiency and performance to a point where real-time proving is a practical reality. So yep, that's the first point. In addition to that, as I said on the previous slide, this is kind of the first step towards enshrining. I feel like the general community would have more confidence and be more comfortable with enshrining proofs, execution proofs, once we have data to kind of and evidence to prove the fact that this is in fact reasonable direction and sound. In regards to kind of the status, we have both the consensus layer and execution layer specs defined and largely settled. I suspect that once we get some more eyes on this, we may have some questions or disagreements which we can resolve, but I don't expect them to be huge divergences to what we currently have. We also have both consensus layer implementations and execution layer implementations. So the stack is maturing. It's in a pretty good state as is, and yeah, it's fully opt-in. So in regards to validators that do not opt in to either of these modes, there's no changes, no implications on on performance. Just a high level on the consensus layer. As I mentioned, we have the two modes: proof generating mode, proof verifying mode. I provided a link to the specs here if anybody wants to review them or provide feedback. We have two client implementations. Internally, we've worked on a Lighthouse implementation in Rust, and the Prism team, Manu specifically, has kindly supported us on this effort with an implementation in Prism. We have deployed some ephemeral devnets. So we have a devnet. We spun up some devnets with Kurtosis, and we performed some interop between the two clients, in addition to having a GPU-based prover. So just to provide a bit more context on the proof engine, the proof engine can be considered analogous to the execution engine. So where the execution engine is a payload validity oracle of sorts that uses re-execution as the backend, the proof engine uses execution proofs. The proof engine's API is modeled on the engine API. This is intentional to make the integration into the protocol relatively seamless. So it has methods for verifying proofs, requesting proofs, and also for notifying of fork choice updates. We have the kind of the core type that we introduce is this signed execution proof. So this is the proof that is generated by an opt-in proof generating node, essentially a validator who signs the proof and then gossips it on the subnet. On the request response domain, we have 3 new methods, so proofs by range, proofs by root, and execution proof status. And then for discovery, we introduce an additional key value pair, which is eProof, and that just signals to peers that we support execution proofs. Just quickly to touch on infrastructure, we have collaborated with PandaOps and implemented support for this EIP in addition to GPU prover support. So it's in a relatively good state, and it's pretty efficient and nice to deploy this, the deployed network, DevNet, sorry. In regards to observability, we've implemented observability. So essentially Prometheus metrics for both ZK Boost, which is the prover backend, and Lighthouse as well. We have Block Explorer modifications where we can kind of observe these proofs. And I've also provided links in case anybody wants to run one of these DevNets. I'll hand over to Ignacio for the EOS stuff. Ignacio, are you there?
We can't hear you, Ignacio.
Yeah, maybe I can cover his section.
Can you hear me now?
Yes, perfect.
Sorry. Yeah, I will touch briefly on the execution layer side of the EIP. On the execution layer, we have to define mainly what is the program that we are proving execution. Because at the end of the day, from the CL perspective, what we are trying to swap is the engine API call to validate a payload with a cryptographic proof that this execution was done correctly. So the high-level parts of the guest program, which is this program that we are proving execution, are the input validation of the program and transformation into the correct input for the state transition function that we already know, and we have already a spec in the execution specs repo. And finally, we have to do some public commitments to these inputs such that the proof verifier can understand which inputs were used in this guest program execution. So basically, the program that's being proven is a stateless validation of an execution payload. So apart from the program itself, we also define which is this input from the guest program. We call this the stateless input type. And basically what this stateless input type has is what you already can imagine, what you already know is our inputs in the NGNU payload RPC. So you have the execution payload and some extra fields. But it also contains cryptographically verifiable data that is required for execution. This is mainly because a guest program that runs inside a SIG VM is a pure function. So it does not have access to a database with the whole state. So all the data that is required for execution, such as storage slot values or balances or things like that, should also be provided as inputs. And not only it is required to receive the input to the raw values, but also requires to be provided data to verify that this data is correct. So the specs also contains a full definition of how this data is provided. And the main goal here to fully spec the guest program and the inputs is to reduce complexity on running provers, because there's a reasonable chance that we will require multiple proofs using different guest program implementations in the same way that today we have different ELs. And if each guest program receives different inputs, that simply complicates generating proofs, because you might need like different libraries to construct the correct input for the proof. And another pretty obvious benefit of standardizing the input is that this is the stable boundary that we need to properly create tests in the execution specs repo, such that we are sure that we are covering all the important angles of new logic for the guest program execution. So probably the first good step for people to understand the CIP is just read the IP. We have been iterating on that these last days, and it's in a really good new shape. But if you want to know like further details, here we have some links to the spec. No, just go to the previous one. So yeah, so you can see here like more details, structs of the definitions in the spec. We also have a bunch of tests already that cover most of the important angles of the guest program doing validations correctly and with correct and incorrect input. We are also doing releases, which are usually based on the latest val devnet. So this is trying to always simplify ELs running these new tests on their main working branch. So maybe no, next slide. So if you want to join the discussion about the CIP, we have monthly CGVM breakout calls. So here we leave the link. Also in the R&D Discord server, we have two main channels for discussions. We have the L1 CGVM channel, which is mainly focused on concrete CGVM infrastructure discussions. And we have the L1 CGVM protocol channel, where we usually discuss CL and EL related topics about this EAP. If you want to read the latest versions of the EAP, we leave an open PR that is still under review. Please try to read this new version instead of the currently active one, because it's a bit stale. And yeah, you can also drop your thoughts or questions in the ETH Magicians thread. And usually we also write articles about this topic, mainly touching in other dimensions such as security in our team's website and blog. So yeah, you are also invited to read that thing. And yeah,
do
that's mostly
we
from
do
our
we
side.
want to do some questions? I think we still have 5 minutes on time. I'm happy to end the call today with just questions on the topic.
Yeah, sounds good.
Open floor for people. So if anyone has questions, please speak up. Yeah, I guess Lackland has a question. He didn't catch why we would need protocol changes for an optional mechanism.
Right. I think this is a really good question, and probably the main one that we have been receiving from people. The way we think about this is that doing this change requires a lot of work on two things. The first one is, for example, in the execution spec work for this EAP, it also requires a lot of changes in the testing framework and main architecture of how a lot of tooling works. And I see also asking for scheduling an EIP into a fork as having a slice of capacity of many teams to really look into this stuff, because there are some like architectural changes that requires also capacity from other people. And I think like trying to do this in a one go in a single fork will be quite challenging, and it makes things pretty hard. And I think the other reason is we want to gather much more real data about how this would work in the real network. So we are trying to do as much work as possible to discover like more unknown unknowns that we might be missing, and trying to push this as an optional feature into the network is the best way to do this without putting at risk main core parts of how the network works.
Okay, thank you. Yeah, that makes sense. It's mostly about teams allocating time, effort, testing effort, and so on for the feature in the slotted fork, right? Photos, do you want to go next and Barnabas
Just a
after?
quick question. Is the verification of the proof, the reply that it's verified or not, does it come as in the reply to new payload call to the engine, or does it come separate?
No, that comes separate. So the notify new payload essentially just makes the proof engine aware of the payload, but the actual verification of the proof is a different path. So let me just show you on this. So yeah, notify new payload, that just lets the proof engine know that a new payload has arrived, such that when the verify execution proof path is invoked via the receipt of an execution proof, it can associate the two via a commitment. But in any case, it can associate the two. And just on the question in the chat, there is no gating of attestation on proof verification. So as far as I'm aware, the gate for attestation is validity, the validity of the block to be, the payload has to be verified before an attestation is made, and the fork choice block validity is exclusively gated by re-execution. So and this notify new payload is fire and forget. There's no actual verification done here. It's just a notification essentially.
Thank you. Barnabas and then Tony. Okay, Tony.
Why would we do that for validators and not for full nodes, assuming that validators would then opt into propagating additional objects over the wire and could be slowed down through that?
So I'm not sure if I completely understand the question, but full nodes can certainly opt in to be they can opt into the proof verifying mode. The reason that we want the proof generating mode to be done by a validator is primarily for DOS, such that we can have a validator kind of sign the proof. But yeah, that's kind of the general intuition. I'm not sure if that answered the question.
Yeah, thanks a lot. And we can also take it async as we reach the end of the call. But thanks a lot. I think I get it.
Yeah. Thank you guys for presenting. There were 2 EIPs we didn't get to today that we can start off with next week. We have return deposits for listing credentials and custom suite thresholds for validators, but we'll push that to the next ACDC. Thank you everyone for coming and see you next time.